With the order tracking feature from the sales order, we have found out that the order is being supplied with production order 1011003. From our order processing menu group, we click Production Schedule. When first opened, the window is set to the so-called Resource View. This time, we are not here for capacity planning, so we select the Production Order View on this View button. In this view, we see all existing production orders in the system listed in the left pane. Each production order status has a unique own color. The 4 existing production orders are also expanded here because there is room on the screen to do so. If more orders were listed, some would be collapsed and a vertical scroll bar would appear to the right of the interaction pane. That's what we call the center area. We can collapse and expand the different levels of information as required. Remark: Assembly Department is the work center used, and Mike Siemens, etc. are the different machine centers performing different operations. The top horizontal pane is the time scale. To expand the scale to show more days, we can simply click anywhere on the scale and drag it left or right to adjust the scale. Another quick way to expand the view is to zoom in using these smart zoom keys. The total scope of calendar days that can be shown on the timescale can be set up in the system. Let us quickly go out and look at this setup. Here we can enter a starting date and ending date to define the total horizon relative to today's date. The current setup of -1 day as starting date means 1 day before today's date, represented by the vertical red line in the production schedule window. The last setup field defines whether operation progress is shown as time spent or quantities produced, both of which are recorded on output lines as demonstrated earlier. In a minute, we will be looking for a progress value of quantity, and we therefore select that setting now. Remark: Of course, this would normally be a fixed setup. To the left, we clearly see the order number. If we need details about the order, we simply leave the cursor over the order description, and a tooltip text appears with relevant details. Such tooltip information is available for practically all data elements in the production schedule window. In the interaction pane to the right of the order description, we see the actual operation scheduled for the order. Again, a tooltip text for each operation will confirm that we are looking at the right order. We are looking for progress information about the last operation. To get a clearer picture of the operation sequence, we can right-click in one of the operations blocks and select Show Links. Also, right-click anywhere in the interaction pane and select Show Progress. Now, we clearly see which operation is last, and we see blue bars representing progress. For these short operations, we need more visible progress detail, and we therefore activate tooltip texts for the last and then second last operation. Here we see in the progress percentage text that the last 2 operations have a few pieces remaining, 87, 5% finished. Remember earlier that we only recorded 14 as output on the last 2 operations. This red square represents the production order due date. The salesperson now has a clear impression of order status and will probably reply to the customer that the order is progressing as planned and will ship on the promised date. Because no changes were made to the schedule, we can simply close it without saving. Now we take on the role of the production planner, who must perform some rescheduling because of changes to an existing order. The customer who ordered 10 bicycles to be supplied with released order 1011004 has made a last-minute request to increase the quantity to 50 and then accept a slightly later delivery date. We will start by adding 1 day to the due date to see if we can squeeze it in. To implement in the order line the changes made in the header, we now refresh the order with the default settings. Okay, that's it. The changed production order line is now planned. The production planner knows that he had a balanced production schedule before this change was introduced. He therefore now enters the production schedule window to resolve any problems that may have occurred. Because we opened the production schedule from a specific production order, that order is highlighted with blue operation blocks in the interaction pane. The gray background represents non-working hours. Therefore, some operations are cut up over more working days. In the bottom pane, load histograms are displayed for every resource performing the operations. The individual load values are right under the related operation. We clearly see that Machine Center Linda Mitchell has a problem because she has been assigned too much work assembling the 50 bicycles just introduced in the schedule. Load histograms can be turned on and off with these check marks for every resource listed under production orders. We can only select and deselect when in the resource view. However, we can see selected load histograms from the production order view. To resolve the overload, we go back to the resource view, which is better suited for the type of capacity planning we will now perform. To get a better overview, we want to show links. Aha! It looks like we could move Linda Mitchell's work to Brian Walton, who has available capacity in that time slot. That would resolve her overload. Oh yes, of course. She has already started and finished 14 pieces, so we can't move her work. We will answer no and try other ways to resolve the situation. Okay. It seems this changed order cannot be finished within the optimistic due date of 1/2/01. We will have to push the order forward to a later ending date. Let us show links for the changed order before we decide how to reschedule. This third operation is causing the overload, so let us try to place it here. Then it will finish late in the day on 1/2/01. Here the system tells us that the operation sequence is violated because the third operation ends after the last. Here we can use a smart function to realign this. First, we click Yes to make the move, and then we right-click on the third operation, which we just moved, and select Schedule Next Operations. As you can see, we also have options to reschedule the one before this one, and we can also undo all rescheduling by restoring the initial values to undo all changes made since we opened the schedule. Now the last operation is sequenced correctly, but it has passed the due date indicated by the red shading. Let us go to the production order view to see this more clearly. Right, this is an acceptable schedule. The overload at Linda Mitchell is gone, and the changed order has a new realistic ending date. To save, we simply escape the window and select Yes to save the changes. As we come back to the production order, we see right away that the ending time has been moved forward to the afternoon of 2/2/01. This update is not yet implemented in the header. Just move the cursor to the header and the database displays the new due date resulting from the rescheduling we have just performed. As the last thing, let us quickly check that the new schedule is in balance. Yes, everything looks fine. Now we can inform our customer that his 50 bicycles will be delivered a day later than requested. This concludes the demonstration of graphical production scheduling.